I'm going to give you a quick review on factoring. What is factoring? Factor is both a noun and a verb, just like water. You can drink water, which is a noun, or you can water your lawn. Factor, as it's used here, factoring is a verb, but it also means that you're going to be finding the factors, which are nouns. Okay, 21. If I told you 21 is a product, then you should be able to tell me that the factors for 21 are what multiply to make 21. Let's say 3 times 7. Those are two factors of 21. There are others, but I'm not going to worry about them at the moment. That's one way to make it. So when I ask you to factor, if I'm not specific, then just give me what two things that multiply, or 2 or 3 or 4 or however many that multiply to give 21. You could have said 1 times 3 times 7 also, correct? Right. So what the problems really look like is something like this. And it says factor. What multiplies to give you x squared plus 3x? Be x times x plus 3x. Because we started on the left side, they taught you that first. They taught you the distributive property, which makes a product. But now we're telling you to go backwards. We're going to give you the product and factor it to give me the factors. How about this one? Well, you know that trinomial usually factors out to two binomials. And we'll talk about how this process is done, but this is what it looks like. You have two factors. X plus 1 is a factor, and x plus 2 is a factor of x squared plus 3x plus 2. Here we go. Factoring. First thing you need to do, absolutely the very first thing before you try to do anything else, is factor out GCF, greatest common factor. If there are any, if you're taking notes, you gotta write this down. Okay. GCF, especially when it's higher than a quadratic. If it's the 4th power, if it's to the 8th power, look for that GCF that makes it into a quadratic, because in algebra we mostly factor quadratics, and if they're higher than a quadratic, then kind of see if they're trying to trick you by making more x's in there than we really need to by having a greatest common factor of an x or an x squared or x cubed. You take that out, and then all of a sudden it becomes a quadratic, and you can factor it. So here's an example of factoring out GCF. 2x plus 10. See if you can figure out what the greatest common factor is, and then factor it. The greatest common factor for that would be, you can pause it here if you want to try. If you know, then here we go. It's a 2. 2 is the greatest common factor for 2x plus 10. So you can factor out the 2x, and you can always check to see if you factored it correctly by doing the multiplication. And you multiply, you should end up with your product, which they gave you to start with when they asked you to factor. How about this? What's the greatest common factor here? Pause it if you want to try it. I think it's going to be 3x. So when I factor out the 3x, I get x squared plus 3x plus 4. Now usually from here, the part that's inside the parentheses, the factor that's inside the parentheses, can be factored again, but not always, as in this case, it's not factorable. So you are finished. This is completely factored. Okay. Other things you should get out of the way is factor by grouping. When you see 4 terms and it's actually to factor, it probably is factor by grouping. What does it mean by that? You're going to take this 4-term polynomial and you're going to split it right down the middle in half. You spread it apart. Now you're going to factor them separately. So if you've tried to factor them separately, since you only have 2 terms, you're going to be looking for a GCF. Always look for GCF. So the GCF for x to the 4th plus 3x cubed should be x squared. And then when you factor out, you get x plus 3. And then on the second part, the other 2 terms that are on the right, you can factor out a 2x, and you get x plus 3. Now, if you end up with an x plus 3 and an x plus 3, you see those common factors at the end there in parentheses? Then that means you can finish this with a factor by grouping. Then you're going to just write two parentheses, grab your x plus 3 and put them together. Don't write a squared on that because it's not squared, it's just 1x plus 3. And then you grab what's left over and you put it in the other parentheses. So now if you distribute going backwards the x plus 3 onto the other binomial, you should end up with the step right above it. Okay? So if you distribute this x plus 3 onto the x squared, 2x, you'll get this term, and you distribute this onto x squared, you'll get the other term. Now that's completely factored as a factor by grouping. Okay, the other type is when you have a trinomial. And trinomials can be factored with an X method. You can do a guess and check, but I think the X method is the most straightforward. But first check for special products. You can go straight to the factor by grouping, but I like to look for my special products because it makes my life easier because I can do it just by looking at it. So what I mean by that is if you have what we call a difference of squares, then I know that that's going to be x minus 3 and x plus 3. In other words, the square root of x squared is x, and the square root of 9 is 3. So I'm going to make a difference of squares. Here's my difference. One is positive, one is negative. That's a difference. And if they were both the same sign, I could square it. But since they're not, I can't. So that's why they call it a difference of squares. And the other special product, there's only two, is this thing here. This would have looked like the one above it, except there's a plus 6 in the middle. The plus 6 is because it is x plus 3 times x plus 3, and we call this a perfect square trinomial because I can write that as a square. So this is this trinomial over here, this 3-term polynomial, is called a perfect square trinomial because you can get it to look like this. Alright, how you can always tell is take half of the middle and square it. Okay, so like x squared plus 10x plus 25 would be a perfect square trinomial because you can take half of the 10, square it, and get the 25 on the end. So this is a kind of a summary of what you need to do when you hear the word factoring. So we're going to practice a few right now of the x factor. Okay, we're going to factor with the x method, or what we call the x factor. You start off with a trinomial, 3 terms. It usually only works with the trinomial. And we're going to put a big X. I'm going to fill this in. On the top part of my X, I'm going to put a times c. The a is the coefficient on the x squared number or term, and the b is the coefficient on the x term, and the c is the constant term, or the one without any x's. So x or a times c goes on the top part of my x, which in this case is negative 12 times 1, because a is 1. And then, what number haven't I used yet? B. I haven't used the b yet, and the b goes in the bottom. And then that's b for bottom, right? And then you put that 1 there. Okay. AC go on the top. AC is good, especially on a hot day, goes on top. And b for bottom goes on the bottom. Alright? And these numbers, the negative 12 and 1, represent the product and the sum. So I can guess that two numbers that make negative 12 and 1 would be a negative 3 times a positive 4 gives me a negative 12, and negative 3 plus the 4 gives me a positive 1. The most errors that are made here is we get the signs wrong, so you got to be careful with that. Okay, there's one more step here. Because there was a 1 in the front, we need to divide both of these by a. But because it's 1, I can usually skip this step because dividing by 1 doesn't change anything. Okay, so that means my factors, always write your factors like this. put two parentheses and put the x, and then you're going to put the -3 in one of them and the +4 in the other. Then you've completed your factoring. How's that? That's the x method. Okay, let's go through another one. Let's try one where a is not 1, like this one. So since a is not 1, we still make the big X. What goes on the top? AC. I like AC on a hot day. So 2 times -4 goes on the top, which makes -8. And then B goes on the bottom, right? So that's -7. Now we want the product of -8 and the sum of -7. Some people see this one as kind of a challenging one because the numbers are so close together. But if you think about it, this is not really that bad. It should be a -8 and a +1. Right? Okay. Now don't forget this step. A lot of people forget this step too. They forget to divide by a, which is 2. All right, so -8 divided by 2, you always have to reduce, and that should give you a -4. And then the 1/2 can't be reduced, so we're just going to go ahead and write my answer as x minus 4, and then 2x plus 1. Whoa, where did that come from? We don't factor with fractions, so we just take that denominator and we move it to the front. So it would have been x plus 1/2, but we move the 2 to the front because we don't factor with fractions. Okay? Now here's one more for you to try. How about that one? See if you can work it all the way through. Put a great big X on your paper, and then just fill in the top, the bottom, and figure out what makes the product and the sum. In this, okay, if you have finished it and you want to check your answer, here's my 2 times 3, which is 6. -5 goes on the bottom. What makes 6 and -5? This particular example right here is the most confusing or the most mistaken combination. 6 and -5. See if you made that mistake. A lot of people want to do 1 and 6. But you can't ever make this work with a 1 and a 6. Because it's really a -3 and a -2. Think about it. Your 1 and 6 don't work because they either have both negative, which will give you a -7 on the bottom, or if they're both positive, it'll give you a +7 on the bottom. Okay? All right. So here, we're going to divide those by 3. Reduce my -3 over 3 is -1, and I'm done. Okay, just remember that the x minus 2/3, you can't have a fraction, so you're going to move that 3 to the front. Okay, I want to give you a recap of the 5 steps for using the x factor. You're going to put a times c, the AC on the top, b on the bottom of your x, and then you're going to, that's step 1, and then you're going to find what 2 numbers make that product and make that sum. That's step 2. Step 3 is to divide it by a. Step 4 is to reduce, and then the last step is to just put it in with the parentheses with the x. And remember to move the denominator in front of the x. And that's it. Hope that helps.